Ever found yourself writing the same code over and over again in different parts of your project? It's tedious, right? This scenario is all too common in the world of programming. You're essentially stuck in a loop, recreating the same code snippets, which not only eats up your time but also makes your project less efficient. This redundancy leads to a bulky, unmanageable code base. It's like dealing with a tangled ball of yarn. You pull one string, and the whole thing unravels. The result? A maintenance nightmare. But what if there was a better way? A way to write code that's cleaner, reusable, and easier to maintain. This is where object-oriented programming, or OOP for short, enters the picture. It's a paradigm that allows us to organize our code into neat, self-contained units, making it less cluttered and more manageable. That's where Python classes and objects come in, to save the day. So, what exactly are these classes and objects we're talking about? Let's start with a simple analogy. Imagine a blueprint for a house. The blueprint lays out all the details about the house. How many rooms it has, what materials are required, where the doors and windows go. But a blueprint itself isn't a house. It's just a plan for building one. In Python programming, a class is like that blueprint. It's a plan for creating objects. A class defines the properties and behaviors that each object of that class will have. But remember, just like a blueprint isn't a house, a class isn't an object. It's just a plan for creating objects. So, what's an object then? An object is an instance of a class. It's like the house you build using the blueprint. Each house you build using the same blueprint is a different instance of that blueprint. Similarly, each object you create using the same class is a different instance of that class. Let's consider a real-world example. Suppose we have a class called dog. This class defines properties like breed, color, and age, and behaviors like bark, wag tail, or fetch. These properties and behaviors are common to all dogs. But each dog, or each object of the dog class, can have different values for these properties and behaviors. For instance, one dog object might be a black, 3-year-old Labrador who loves to fetch, while another dog object might be a brown, 5-year-old beagle who prefers wagging its tail. In this way, we can create as many dog objects as we want using the dog class, each with its own unique properties and behaviors. And this is the beauty of classes and objects in Python. They allow us to create complex data structures in a manageable way, making our code easier to write, read, and maintain. So, a class is like a blueprint, and objects are the actual things you build using that blueprint. Now that we know what classes are, how do we create one in Python? Well, the first step is to use the class keyword. This keyword tells Python that we're about to define a new class. So, let's say we're creating a class for a dog. We would start like this: class dog. That's it. We've just created a new class in Python named dog. But wait, we're not done yet. Python uses indentation to define the scope of the code. So, everything that belongs to our dog class should be indented under the class definition. Now, our dog class is pretty empty at this point. It doesn't really do anything. That's where methods come in. Methods are essentially functions that belong to a class. They define the behavior of the class. So, let's give our dog class a method. We'll start with a simple one, bark. We define it just like a normal function, but remember it needs to be indented under the class definition. So, we'd write something like this: class dog. Notice the self parameter in the bark method? That's a special parameter that Python uses to refer to the instance of the class. It allows us to access the attributes and methods of the class within the method itself. So, we've added a bark method to our dog class. Every time we call this method on an instance of our dog class, it will print woof. In a nutshell, creating a class in Python involves using the class keyword, followed by the name of the class with a colon. The methods and attributes of the class are then defined under the class name, indented to denote that they belong to the class. And just like that, we've created a class with its own methods. But how do we use it? Well, that's a topic for our next scene. So, stick around. We've got our blueprint, now let's build something. It's time to move from theory to practice, to create and use objects. Remember our dog class from the last scene? That's our blueprint. Let's construct an object from it. In Python, creating an object from a class is as simple as calling the class as if it were a function. So, if we wanted to create a dog object, we'd write Fido equals dog. Here, Fido is an object of the dog class. Now, what if our dog class had properties like breed, age, and color? We'd pass those as arguments when we create the dog object. So, Fido equals dog, Labrador, 7, black, creates a black Labrador named Fido who is 7 years old. Next, let's talk about accessing the properties of an object. We do this by using the dot notation. So, Fido, breed, would return Labrador. Similarly, Fido.age would return 7, and Fido, color, would return black. But our dog class isn't just about properties, it's also about actions or methods. Let's say our dog class has a method called bark. To make Fido bark, we'd write Fido, bark. This calls the bark method on the Fido object. Let's create more objects. How about a bulldog named Bruno who is 3 years old and brown? Bruno equals dog, bulldog, 3, brown. And a poodle named Princess who is 5 years old and white. Princess equals dog, poodle, 5, white. Now, we can call their bark method. Bruno, bark, will make Bruno bark, and Princess, bark, will make Princess bark. And that's how you create and use objects in Python. Use the class as a blueprint, construct objects with it, access properties with the dot notation, and call methods on the objects. And there you have it, we've created and used our very own Python objects. But why go through all this trouble? What's so great about OOP? You might ask. Well, let's put it this way, object-oriented programming, often referred to as OOP, is like a Swiss Army knife for programmers. It's versatile, it's powerful, and it can make your life a whole lot easier. One of the key benefits of OOP is code reuse. Imagine you're building a skyscraper. Would you want to craft every single bolt, nut, and steel beam from scratch? Or would you prefer using pre-made components that you know are reliable and fit for purpose? The same principle applies to programming. With OOP, you create classes. These are your blueprints, your pre-made components. You can use them to create objects over and over again, saving time and effort. But there's more. OOP also promotes encapsulation. This is a fancy term for the practice of hiding the internal workings of an object, only exposing what's necessary. Think of a car. You don't need to know how the engine works to drive it, right? You just need to know how to operate the steering wheel, accelerator, and brakes. Encapsulation in OOP works the same way. It hides the complex code and presents a simple interface, making it easier to use and less prone to errors. And let's not forget modularity. This is the concept of breaking down a program into smaller, manageable parts or modules. It's like assembling a puzzle. Each piece, or module, is independent yet contributes to the overall picture. This makes the code easier to understand, debug, and maintain. So, to sum it up, OOP allows for code reuse, promotes encapsulation, and encourages modularity. It's a powerful tool that can lead to more efficient and maintainable code. And the best part? Python makes it easy to implement these principles, so you can focus on solving problems and creating amazing applications. So, with Python classes and objects, we can write better, more efficient code. Pretty cool, right? Alright, it's time to put your knowledge to the test. Let's see how well you've grasped the concept of Python classes and objects. Question 1. Can you explain what a class in Python is? Think about it as a blueprint or a set of instructions to create an object. Moving on to the second question. How do we create an object from a class? It's as simple as calling the class, isn't it? Now, for the third question. Can you describe what object-oriented programming is all about? It's about creating reusable code, isn't it? And finally, question 4. What is the difference between a method and a function within a class? Keep in mind the self parameter. Don't worry if you're finding these questions a bit challenging. Remember, practice makes perfect. So keep coding, and you'll master Python classes and objects in no time.